Hi everyone, welcome back to my session. So this is going to be a problem solving series, okay, where I will be taking very good problem from PYQ, previous year questions. In fact, I'm starting from instrumentation branch because you don't find the solution or any sort of PDF across the social media as well. And I will be giving you the smart solutions, right? So I have picked up some question from PYQs, okay, and these questions are from basics only, right? Some basic concepts are there, like we have to use KVL, KCL, and how smartly you can solve the question, that we have to learn, because I know you might be able to solve the question, but how smartly you can solve the question, that matters a lot, right? So let me take a look. The very first question I have taken, which was asked in gate 2010, right, in 2010 in instrumentation branch, right? And next question I have taken in which was asked in gate 2020, like 2020. So you will also find that the PYQs are, the concepts are also repeated, in consecutive years, if you see, right? So this is one question, and the next question I have taken from 2020 only, right? Where you have to simply form the matrix, okay, by applying some mesh, okay. And this is again one more question, okay, and this is 16 question, 2012 question, and 2012 again, right? So the language which I always speak, you see the impedance looking into the node 1 and 2, right? So whenever you are trying to find some resistance equivalent, okay, so we always try, what we always do, we always look back to the circuit, right? So let me start with the first question, right? The very first question that I will be discussing now, okay. See, though I have taken first question as a 2010 question, but I will be talking the first question as 2020 question, right? Based on this question, the previous question can be done, okay, based on the concept we are going to use, right? So what is the question here? In the circuit shown below, the safe maximum value for the current I is what? So all resistors are given here along with the power rating they have given mentioned, okay. Some power is mentioned, okay, across the resistance, okay. As you can see, this is 100 ohm, this is 1 watt, and this is 2 ohm, 0.5 watt, 1 ohm, 0.25 watt. You can consider these are the bulbs kind of thing, like bulbs are connected in series, right? So what is the question here? We have to find the maximum safe value of for the current I, okay. So you guys can also try. I'm just going to give you the solution here, right? So what you have to first of all find out is, you have to find the current, you have to find the current, because of this 1 watt, how much current it can take, this resistor can take, how much current this resistor can take, how much current this resistor can take. And if all the resistors are, or you can say resistances are connected in series, so what will be the maximum safe current that you have to find, right? Okay. So let me find here, because of this, what is the relation between current and the power? Basically, power is nothing but I square R. I square R is power. We can find I square is going to be what? P by R, which is I is going to be what? You can say square root of P by R. Okay. It's so simple. Okay. Now what you can do here is, here we can find I1W, right? Because of 1W, because across this, you can say through this resistance, how much current is flowing, you can say. So power is given as 1 watt, right? So you can say 1 upon resistor is 100, so you can say this is going to be 1 by 10, which is 0.1 ampere, right? Simple. 0.1 ampere that you can write, and you can find the current through this resistance. You can say 0.5 watt we are going to find here. So it is nothing but 0.5 upon the resistance, which is given as 2, okay. So you can simplify this. It is nothing but 5 by 20, right, which is square root of 1 by 4, and now you can say this is going to be 1 by 2, which is 0.5 ampere, right? 0.5 ampere, you have got the second current, okay. Now because of third resistance, how much current this resistor can tolerate, you can say, because we have to find maximum safe current, okay. Like suppose you consider these resistance as a bulb, okay, and bulbs are connected in series. So how much maximum safe current should flow through this circuit, so that all bulbs are safe, okay, they should not blow up, right? they should never blow up, right? So it is very important. You have got here. Now you can also find, this is the first step that you have to recall, and then this is the second step, this is the third step. Okay, these are the steps. And now the fourth step is what? The fourth step is basically you can find I 0.25 W, right? Here the power is given 0.25, so you can write 0.25 upon 1, which is nothing but again 25 by 100, right? You can solve this. Again it is 1 by 4, which is 1 by 2, which is 0.5 ampere, right? So you can see here the current which is flowing through this resistance is 0.5. Okay, yeah, hi Raviteja. Fine. So this is current is flowing through, this is 0.5, again 0. So what is the maximum value for the maximum save value? Okay, save value you can say for the current I. So always keep in mind this concept. Okay, this is very important concept. Whenever the resistances are connected in series, or any sort of device which is connected in series like bulb, right? Okay, so what you have to always keep in mind, you have to find the current, individual current, right? Okay, and then the maximum save current, right, is going to be the minimum of what? You can say I1W, I 0.5 W, and I 0.25 W, right? Okay, so what I minimum among all, you can say 0.1, 0.5, 0.5. So what is the answer here? What is the minimum of among 3? The minimum is gonna be 0.1. So answer is A. Sorry, not answer is A. You have to find 0.1, right? So option is C, right? So answer is gonna be C. I hope this makes sense to all, right? So what is the question here? In the circuit shown below, the maximum safe value for the current I. Okay, maximum safe value for the current I. See, if suppose they have connected capacitances, right? So they always find, they always ask what will be the maximum voltage that you can apply across the capacitance, right? So that your capacitance will not be in breakdown. Okay, will not break down, you can say, right? So in this case, they will mention the power rating. Okay, power rating, right? So this is one of the very good concept that I got to see while solving the PYQ, right? Gate 2020. It is repeated question, guys, no doubt. Okay, but you should know the algorithm. क्या algorithm है यहाँ पर है? आपको individual current find करना है, and the minimum current can be the maximum save. See, maximum save current is what? The minimum of C current. Okay, so I hope this makes sense. So answer for this question is 0.1. Okay, 0.1 is the correct answer for this question. I hope this makes sense to all. Let me come back to the question which was asked in GATE 2010, instrumentation branch, right? Instrumentation branch. Okay, the similar circuit you have to design. Okay, here you see, if suppose in this question, in the same question, they are asking what is this maximum safe voltage, you can say maximum safe voltage, right, that we can apply across this combination. So can somebody find out? So you can solve this question. You can also find VB, that is maximum safe voltage, right? So the maximum safe current which is flowing is 0.1. So across this you can find the potential, right, because of 0.1, because of 0.1, because of 0.1, and then you can add it, right? You can apply the KVL, right? You can apply the KVL and you can find VB also. So I'm just showing here the VB, right? The VB business. Though in this question they did not ask you to find VB, but you can find VB as well. Since you came to know that the maximum safe current which is flowing through this series combination is what? 0.1 ampere. Okay, so each resistance should take 0.1 ampere. So there will be a drop of you know how much? 0.1 times, you can say. So there will be a circuit, you can say 0.1 times 100 means 10 ohm, sorry, 10 volt, sorry, it should be 10 volt, right? Fine, this is 10 volt, you can say, across this, and here 0.1 means you can say 0.2 volt, right? And then here it will be 0.1 only, right? 0.1 volt. Now you can add it, I mean you can apply, not add directly, you can apply the KVL, right? KVL क्या होता है मैंने आपको बताया था, just KVL, right? you can find VB. You can apply now KVL, right? So KVL means you have to take first sign here, right? So you can take first sign, okay, and you can solve it. Okay, yeah, maximum safe voltage that you can find out is 10.3, right? I mean, Ravi Teja has done here. So 10 and 0.2 plus 0.1, so maximum VB is going to be 10.3 volt. So whenever any question is given, you have to analyze the question very carefully, guys. Analyze the question very carefully so that you can predict that, yeah, this kind of question might be asked in the next exam. Fine. So this is one question, and this is one of the very good question again. What is there? The 100 ohm 1 watt resistor and 800 ohm 2 watt resistor. These are the power rating they have mentioned for resistance, guys. Remember, okay? Okay, this much, okay, power that resistor can, yeah, okay. Like in case of capacitance, what they do is they mention voltage along with the capacitance value, right? Break down voltage they mention, right? So this question, I think 2010, and that question was asked in 2020. So repeated question, you can say, right? So analyze the PYQ very carefully. 100 ohm 1 watt resistor and 800 ohm 2 watt resistor are connected in series. The maximum DC voltage that can be applied continuously to series circuit without exceeding the power limit of any of the resistor, right? So what you can do here is you can draw the resistance here, right? Or you can also draw the bulb, right? And connect them in series, right? And here you connect one battery. You can say the battery is VB. This is the maximum DC voltage that we can apply. So rating you can connect like 100 ohm 1 watt, and this is 800 ohm and 2 watt, right? So the very first job, what should be the very first job? Okay, you have to find the minimum current, right? जैसे कैपेसिटेंस में हम लोग क्या करते हैं, what we do always in capacitance, we try to find the charge, okay, charge across the capacitance, right? And the maximum charge that, okay, it can have. So here what we are doing here is, you see, Q max there we find, okay, here we have to find minimum current, right? So remember, okay, so first of all you can find the current. So current you can find here, current you can find here, then take the minimum and allow that current to flow, right? So you can say that 1 watt, because of 1 watt the current is gonna be 1 upon 100, right, which is power upon resistance, right, which is 1 by 10, which is 0.1 ampere. In fact, without using calculator you are able to do these things, right? Okay, so one current because of 2 watt, through this resistance you might expect 2 by 800, right? Because of this you can say it will be 1 by 400, and because of this it is going to be 1 by 20, right? Because 400 square root is 20, right? So 20, 1 by 20. Okay, so what is 1 by 20, guys? 1 by 20 you can compute, right? So 1 by 20 is going to be around 0.05. Yes, Ravi Teja, can you try what will be the current here? I mean 1 by 20 is how much, right? So we can use the calculator also if you don't have. 1 by 20 means 0.05 around, right? Yes. So what we can do here is, yeah, you try to calculate this and try to find the minimum current. So yes. So 1 by 20, we are trying to calculate 1 by 20, right? So it is nothing but 0.05 that I told you. So it will be 0.05, okay, ampere, right? Now you just find the maximum safe current. The maximum safe current is going to be equal to what? The minimum of 0.1 and 0.05 ampere, right? You don't have to waste time, guys. Don't think anything, just find out the current. Okay, yeah, 0.05, fine. So since we got 0.05, now 0.0, what is the potential drop across this? Okay, so in order to find VB, maximum DC voltage, right, you draw this circuit, right? So this is VB, which is maximum we have to find. Now we know that the current which is flowing through this 100 ohm, and forget about now the power rating and all, right? So this is 800 ohm, right? What you can do here is current which is flowing is, you can say here 0.05. So 0.05 into 100, which is 5 volt only, and इसके across कितना हो जाएगा? It will be 40. Right? 800 into 0.05 is 40. Now you can apply it, right? So answer will be 45. Okay, the VB max is, you are going to get is 5 plus 40, which is 45 volt. I hope this makes sense to all. So without any kind of trouble, right, you guys can solve this sort of question. I think this concept is clear now, right? Crystal clear. So from this you can expect some question, right? Certainly you might expect question. So these are the two questions which you can expect, and I hope you understand, right? So what is the maximum safe current? The concept is maximum safe current is equal to minimum of all the current. If devices are connected in series, right? If elements are connected in series, right? And the maximum safe voltage, how you will obtain? By finding the maximum safe current first, right? Find the maximum safe current, then you can find. So both questions are, I think both are same. And now this is what the thing is, like if you're properly analyzing the PYQ, then you can expect some question from PYQ as well, right? Okay, at least 40 to 50 marks you can obtain from PYQ, right? If you solve carefully, because I know many people do not solve it, right? Okay, so this question was asked in GATE 2020, right? Okay, and this kind of question we used to do in our college days using calculator, right? I mean, suppose you have to find current and there are three mesh. Okay, there are three mesh and we have to find the current, right? So I1, I2, I3 we have to find. So we need to write system of linear equations, okay, and then we need to solve system of linear equations, right? And since you guys have attended my class on linear algebra, so you guys can solve also the value of I1, I2, I3 you can get, but needless to solve here, you have to just form the matrix, okay? And this is for 2 mark question. Okay, this is 2 mark in instrumentation paper. What is the question here? Let me read. I1, I2, I3 in the figure below are mesh current. The correct set of mesh equation for these currents in the matrix form is what? So you see, first we can apply here, right? So the first mesh, okay, KVL at the rate first mesh, right? Focus on first mesh. Okay. First, okay, and we have to get the if see Ravi Teja, if same resistors are connected in parallel, so maximum safe voltage is what? The voltage which is that you can understand in parallel, the voltage will be same, right? So that similar question we will get, okay? So I will bring back again some sort of questions, so we can discuss these questions. If you have any question in parallel, they are connected, right? So you bring and share in the group, right? So we'll discuss, right? Okay, fine. So let us finish this part, okay? So understand that the same question I was also getting in my mind. If same resistors are connected in parallel, then what will be the maximum safe voltage and maximum safe current? Okay, so you have to think about it and share, right? Fine. The KVL at the rate first mesh, what you have to do, you apply here. So start with first, you can say minus V1, right? Minus V1. Now you see the current is going like this and the current is coming like this. They are opposing each other. So you have to write here the drop, 1 ohm times, you can also forget about this 1 ohm, right? You just write here 1 times what? I1 minus I2, I1 minus I2 plus, you see the current is entering here, current here entering like this, okay? Again they are opposing, so you can write this as plus 2 times of, because we are following the direction of this current I1, right? So if any current is coming in, this branch is actually common between between two mesh, right? Or two loop, you can say. So 2 times of I1 minus I3 is going to be 0, right? Now you can take V1 that side, because you see here they have mentioned all the V constants, you can say, in one side. So this is going to be I1, right? I1 is going to be 2 I1 from here, it is 1, you can say 3 I1, right? And minus I2, okay, minus I3, sorry, 2 I3 which is equal to V1, right? Okay, this is the first equation that you can obtain. And if you have got the system of linear equations, so I think everybody knows how to write in AX equal to B format. Okay, AX equal to B format. ठीक है, सिस्टम ऑफ लीनियर इक्वेशन को कैसे रिप्रेजेंट करते हैं मैट्रिक्स फॉर्म में, आई हैव टोल्ड ऑलरेडी गाइस, यू हैव टू जस्ट कलेक्ट द कोएफिशिएंट. ओके, इट्स अ वेरी इजी क्वेश्चन. ठीक है, नेक्स्ट इज second equation you can get. Okay, there are how many equations? There are 3 equations and 3 unknowns, right? Because the matrix size is 3 by 3 and there are 3 mesh, certainly you will get 3 equations and 3 unknowns, right? Okay, next is second mesh. You can come here, so KVL at the rate second mesh, right? So what is this? Now you are in a second mesh, right? So you have to be very careful. Current is entering here like this, so minus V2, then you can say take this as plus I2. Okay, I2 times 1, and here current is going like this, current is coming like this. Okay, so here again the subtraction of 2 current, but you are in second mesh, so you have to take first I2 minus I3. I2 minus I3, don't make mistake of any kind, right? Because these currents we have taken, okay, clockwise. Yeah. Now you come to this 1 ohm. Again 1 ohm is shared with these between first mesh and second mesh, so you can write this as I2 minus I1, which is equal to 0. So again you can take this V2 that side, so first write I1, so I minus I1, right? And then 1 plus 2 plus 3 I2, and minus I3 is going to be equal to V2. This is second equation. Okay, so you have got first equation, second equation, right? So now what you can do here is you can apply the KVL at the rate third mesh. So this question can be done in 20 seconds, right? So again you see here we can say that entering, right? So it is current is entering like this, right? So you can say this is plus V3, right? Plus V3, and then 2 times of I3 minus I1, then I3 minus I2 equal to 0. This is third, right? So this is third equation, right? Now you can write this as minus 2 I1, and then minus I2, okay, plus 3 I3 equal to minus V3. Okay, so you can say this is third equation, not that. Okay, now you can choose here which coefficient matching. You see 3 minus 1 minus 2, so option C you can say, not option C here. Which option is correct here? You see 3 is positive here, right? So 3 minus 1 minus 2. Okay, and one more thing you have to observe here, yes, only V3 is present here. You see minus V3, so these two options are wrong, right? Option B and option D. Don't look option B and option D. Okay, so I think option A, Ravi Teja has got the option A, right? So yeah, just you have to write, okay, because there are 3 equations and 3 unknowns, so you can write them as a AX equal to B format. B is nothing but collection of these constant potentials V1, V2. So in fact this is also not correct because there is a minus 3, so option C is wrong, option A is correct. I think everybody can write this, okay, so I need not to explain you again, right? You have to just take 3 minus 1 minus 2, okay, and this is the vector, current vector you can say. Now you can also solve this, okay, if V1, V2, V3 is known, so you can find current I1, I2, I3. If V1, V2, V3 is not known, then you cannot find because everything is unknown then, right? Fine. So AX equal to B format se karna hai, right? Chalo. Next question is, in fact we can solve this question again, I mean if you want further, right? So just I'm writing the matrix here, right? So from equation 1, 3 minus 1 minus 2, right? From equation 2 you can say minus 1, 3 minus 1, and from equation third, right? And so this is minus 2 minus 1 and plus 3. Okay, so option A is matching. Fine. This question was asked in GATE 2018, that is 2018, right, before COVID. Okay, so let's see this question, what this question says, right? So you see, always keep in mind one of the very important concepts. Suppose there is a 2 mesh. Yes. that we have talked. Yeah, maximum. In fact, I have discussed one question as well, right? So that you can take. Okay, so remember, when there is a current source between two mesh, okay, जब भी दो mesh है, suppose there are two meshes and there is one current source, ideal current source is connected. So this situation is known as super mesh situation. What? This situation is known as super mesh situation, guys. Okay. This is again 2-mark question, and you have to remember always. Okay, let me tell you here the basic concept. Suppose this is a ideal current source and there is a mesh, right? Like this. Yeah. There is one mesh, there is second mesh, right? So if this is a situation, so you can always apply KVL like this. Okay, this is a super mesh case. Super mesh. Okay, and in case of super mesh, how you have identified there is a super mesh situation? Because you see there are two meshes where one ideal current is connected. Okay, ideal current source is connected, right? So quickly you can apply the one mesh here, right? Like this one KVL equation here, like KVL you can apply. Okay, so you can write here by KVL, okay, at the rate super mesh situation, right? So one equation you will get. So you can start from here. So we are choosing, when current flows through any passive element, right? So it always enters from positive to negative. Polarity is not given, so आप हमेशा लेना प्लस टू माइनस, प्लस टू माइनस, प्लस टू माइनस, राइट? तो आप क्या करोगे यहाँ से, देखो प्लस टू माइनस like this. Okay, always keep in mind when here you are talking, so you take plus to minus, right? So plus to minus, you can say this is 2i1, right? And then plus 6 times of i1 is going like this, i2, so you can say that i1 minus i2. You are in the mesh first. Now you have to come here also, right? Because there is a ideal current source. Okay, so you can go ahead also. So this will be basically equal to 1 ohm times i3 minus i2, right? And then voltage drop across this, that is i3, which is equal to 0. I think this is clear for all, right? Okay, so this is the question that you have to understand, right? Understood? Yeah. Now what you can do here is, next is the second mesh you can come. Okay, second, right? So this is one, so you can simplify this. It will be 2 plus 6, 8 i1, 8 i1, then it will be minus 6 i2. Okay, and there is one more i2, you can say minus i2, it will be 7 i2, right? Okay, because this is minus 6 and this is minus i2, so it is 7 i2. You have to be very careful, guys. Okay, you don't have to make any sort of mistake. And this is going to be plus i3, and i3 plus i3, that is 2i3, right? So you should write 2i3 equal to 0. So this is first equation that you have got, right? Next equation you will get from this. Okay, and third equation, how you will get? Third equation, you have to apply one KCL at this point, right? One current is coming like this, one current is coming, one current is going like this. Okay, so you can apply KCL, right? In case of super mesh, keep in mind KCL and KVL, right? Both we have to apply, fine, so that you can have the current. Otherwise, So in the second, you see we are starting like this, we are going from minus to plus. You can say this is 5. Okay, let me write here KVL at the rate second mesh. Okay, so what you can do here is you can say minus 5, right? Then plus i2 minus i3 plus 6 times i2 minus i1 equal to 0. So you can write here that minus 6 i1, right? Because minus 6 i1 you will get, then 1 plus, that is 7 only, so plus 7 i2, right? Plus 7 i2, and then it is going to give you minus i3, which is equal to 5, right? This is second equation, right? Okay, I hope this makes sense to all. You have got two equations, one equation, two equations. Now third equation you need to have, okay, because there are three unknowns, right? So what you can do here is you can apply one KCL at this point. Okay, you can say this is node A, right? So by KCL, so current is coming, that is I1. Current is here, okay, in this case, flowing, that is, you can say going away, that is I3 is going away, right? I think this is clear for all, right? So the third equation that you can get is current is coming, that is I1, and one current is going away like this. Okay, so how to apply KCL? KCL means entering equal to leaving, right? So you can say that I1 plus 2 equal to I3. So you can say from here I1 minus I3 is going to be minus I2. This is third equation, right? You have got three equations, right? Now you can find out, you can solve these three equations and you can find out. Okay, so I believe everybody can solve this. Okay, so how can you solve this? I think I should give you the hint. You just take this and this. Okay, so what you have to do, equation 1 and equation 2, if you add, so this I2 term will be cancelling, I2 will be cancelling. Okay, so let me take one you can say one new page here, right? So yeah, so you see here I'm just going to add here. So let me copy this and let me copy entire business, whatever we have written here, right? No, not this, basically. Yeah, this is the situation, right? So let me copy entire story what we have written here so that we can solve quickly, right? So here we will copy and paste. Yeah, so what is this, guys? You have to remember, so equation 1 and add equation 1 and 2, right? It's a very simple one. So if you add this, so 8I1 minus 7I2 plus 2I3 equal to 0, and then here it is written 6I1 plus 7I2, okay, minus I3 is going to be 5. So if you add this, this will be gone, right? So 2I1 plus I3 equal to 5, right? Yeah, so this is, you can see, equation number 4. Now equation number 4 and equation number 3, right? You have got two equations, two unknowns, I1, I3 is unknown. So you can apply by elimination process, right? By elimination, you guys can apply elimination. I'm not gonna tell elimination, right? So you can get here the I1 you will get as 1 ampere, and I3 you will get as by solving these two simultaneous linear equations, and then I2 you will get as 1 3, and I2 you will get as 2 ampere. So please solve this. I think everybody can get, yeah, yes, 1 2 3, right? It's a very simple question. So by elimination, equation 4 and equation 3 you have to combine, right? So it's a very easy way of solving question. So we should not take much time. Okay, this is the only way to solve this question. Okay, remember, right? So 2-mark question, it takes little time, but you can get the answer. But make sure don't make mistake, guys. If you make mistake, you will not get. There is no other way of solving this question. Okay, so answer for this question will be what? Answer for this question will be A, right? 1 2 3. I think we have got I1 here, I2, yeah, fine. It's a very easy question, right? 2-mark. Here. Now let's move ahead and take next question. So this question was asked in gate 2016 by ISC Bangalore. You see, very simple question they ask. Okay, ISC Bangalore has asked this question, right? What is the question here? Let us read the question. Current IX in the circuit given below in milliampere you have to find. So whenever any question is given, guys, always keep in mind you have to read the question and you have to be very careful about notice that units, right? Unit को ध्यान में बहुत रखना है, magnitude, units, right? Everything. Okay, so in this case you have to find Ix here, right? So it's a very simple. You can find this potential here V. Okay, because it is already simplified circuit. Okay, many people think that okay, we can apply Thevenin and all and we can get, no. required to apply Thevenin. Already it is simplified, right? It is simple voltage along with the resistance. It is simplified, right? What you can do here is you can just find Ix by finding V first, okay? And if you are able to get V, then V by 100 is the Ix, right? We can apply KCL at this point. Take the ground, okay? The reference should be there, okay? If you are applying KCL, means there should be some reference, okay? So by you can say that this is Vx, right? Vx you can take by KCL at the rate Vx, right? So Vx, okay, so you can take current like this by yourself, okay? Whenever you are applying KCL, you can choose your own way of measuring. You can choose your own direction, right? So there is no problem. So this is the direction, right? So what we can say, V minus 1 upon this is 100 plus going away, right? So Vx, this is Vx by 100 equal to, right? Since this current is coming, so what is the logic here? If you are applying KCL, so current going away and current coming, right? So better to what you can do here is, in this case, this current is coming, so you can choose this current only, since this current is coming, right? So these two currents are leaving, you can say, and this will be coming, so you can say 10 milliampere. So since the base, since these are same, right, the denominators are same, you can say that Vx minus 1 plus Vx is going to be 1000 milliampere. I think, sorry, 1000 milli, so you can say that it will be 1 volt only, right? Okay, because 1000 into milli is what? 1000 into milli is, 1000 into milli is gonna be 1, right? Okay, 1000 into milli is going to be 1, because 1000 into 10 raised to power minus 3, which is 1, right? So it is going to be what? 2 Vx is going to be 2, so Vx is going to be 1, right? Now the answer for this question, you see, you got 1, Vx is 1. So here, what is Ix? Ix is gonna be Vx by 100, Vx by 100, so which is 1 by, okay, which is 1 by 100, right? But you have to find in milli. So what you can do, you can multiply 1000 and you can write milliampere here. So 100 and this is cancelled, so answer is 10 milliampere, right? So answer क्या होगा इसका? 10. Ravi Teja, you got 20 by 3. Is there any mistake in the solution that I have given? Please check it out. So answer will be 10 milliampere, guys. Okay, this is very simple question. So answer is 10. Okay, answer will be 10 here. How smartly I have done, you see, right? So 100, 100. Okay, since the denominators are same, so you can add the numerators, right, directly. Okay, from the very basic concept. So answer for this question is 10. Okay, fine. Let me go ahead. Okay, so you have to be very careful while applying the KCL, while applying, see, this question how smartly we have done. So this is the first step that you have to do, and this is the second step that you have to do. So this problem is of 2 step. Okay, 2 step. Next question, let us take here. Next question. So this question was very good question in 2012, right? In fact, this question was asked in GATE electronics as well, guys. ठीक है. अब इस question में क्या था? In this paper, in electronics, there was 67 marks. 67 marks. One of my, you can say, senior mentor, senior friend, okay, he got 67 marks and rank was AIR1, okay, in 2012. In that year, I met him also, right? I met him via social media and all. Those days, social media was not there, but Facebook was there only, right? So I met him, and he was a guy, he motivated me for GATE, right? So I started GATE journey then, right? So those days I was not familiar with these kind of a question, right? So we used to face a lot of struggle, right? So that's what I planned, that I will be giving all the solutions, smart solutions, okay? So his name is Rakesh Kande, right? Remember? Okay. Currently he is working at Intel, okay, from the past many years. Okay, he graduated from ISC Bangalore from microelectronics. His marks was 67 marks out of 100 from electronics. Okay, and he was a topper in India. He is from Hyderabad. Okay, so I have met personally in the year of 2012 itself. After you can say, because if you are a topper, you are kind of celebrity only. But he is very great guy. He's very simple and very down to earth, right? He invited me and I caught up. So you see this question, what they have given, VA minus VB equal to 6 volt, and then you have to find VC minus VD, right? But these things, if you look back, okay, like between VA and VB, okay, but if you look left side and right side, okay, everything is unknown, guys. You see all resistance are unknown and everything. So what you can think of, this circuit can be thought of like this. Suppose this is network A and this is network, and say network B. So there are two networks that you can consider here. There are two networks, okay. Suppose in this network some current is flowing, you can say some current I1 is flowing, right? So then where this current will go, right? Suppose from network 1 this current is coming, okay. So and this network you can consider as a black box. This is just a black box, okay. This is just a black box. If everything is not known, so then this is a black box, right? So this is a concept that you have to apply. So in black box, current is coming out, that is I1. So this current will go inside this black box too, right? This is again a one black box. ठीक है. अब ये current कहाँ जाएगा? If this current is going, so this current should come back also, right? So from this you can say the current will be I1, same current will flow, right? So it is coming back, right? Coming out from the you can say from one black box and again coming back, okay. That you have to remember. Since you know the potential difference between these two nodes, what you can consider here is that you can consider this is one black box, right? From here to here you can consider this is one black box, right? Okay, and from here to here you can say this is one black box. Please remember, this is one black box. You don't have to worry about this. These are the two networks. And now current you can find from here. What is that current? The current through 2 ohm, you can find out that is going to be VA minus VB by 2 ohm, right? Simple. So VA minus VB, it is again of 2 marks, guys, okay. And you see that year 67 marks was the highest marks, right? Okay. So matlab this question was difficult, right? But it is not difficult, right? It is, you have to understand this, okay. So VA minus VB is 2 upon 2 ohm, that is 6 volt by 2 ohm, which is 3 ampere, right? Now this current is coming, okay, you can say from black box 1, and this will say, okay, I'm gonna enjoy in black box 2, and again I will come back to my home, because my home is, you know, black box 1, right? So this is first circuit, you can say, this is second circuit, you can say, right? Okay, okay. So current is coming, again coming back, right? So you have to focus in this branch, right? This branch, okay? So let me consider this branch separately. Okay, so I'm just gonna take this branch separately, okay? You see this is a branch, okay? I'm just going to take this branch separately between VC, right? There is a current source, there is a VD, right? And there is a 1 ohm, right? 1 ohm resistance, right? And this current has magnitude 1. Now current is coming back, that is, you can say 3 ampere current will be flowing here, right? What you have to find out? You have to find out VC minus VD, means you have to find the difference between the two. Now this current is coming, that is 3, and this current is coming to this node. You can say this is one node, right? So how much current is flowing here? The current which is flowing is 5 ampere. So it is flowing like this. You can say this is 5 volt, then 5 into 1 means 5 volt. Now you have to find VC minus VD. So from here you can say VC minus VD is going to be what? VC minus VD, it looks like minus 5 volt only directly, right? So you should never make you know, the potential difference, right? Okay, across this current source minus 5 volt is there, and that is the potential difference we are looking for, right? So answer for this question is A. What is the thought process? Based on same concept, one question was there in the gate, right? They gave two port, okay, like they gave two circuits, and those two circuit was connected with one resistor, okay, and they asked you to find out the current through that resistor, okay. So if there is no return path, right, if there is no return path, means there is no current, okay. So if there is no return path, means that current should be 0, right? That current should be 0. Keep in mind, this is very important question, right? In fact, when we talk about any equivalent model of the BJT or, you know, any sort of transistor, right? So you might have seen that output port is controlled by input port, right? And in between nothing is connected if we are not considering any sort of bypass impedances and all, right? No feedbacks is there. Understand? अगर आप unilateral amplifier की बात करते हैं, this concept is very good. You see how smartly we have done. So my main job is to give you smart solutions, guys. ठीक है, चलो next. Gate 2012 problem, right? So this follows my language only, right? My language, again, this is for 1 mark. Okay, it is not that tough question, but many people make mistake here as well. You see how smartly I am solving. So since you see here this IB is flowing, right, through 9K 1K, right? So you can simply combine these two resistance. I'm just gonna combine this, right? So it is 10K only, right? 10K, right? And the current which is flowing is IB. Okay? And now you can say that there is a one more 100. This is 100 ohm, right? 100 ohm. And here you have to look back. Okay, from here the RTH, or you can say some equivalent resistance, right? So since this circuit has only dependent sources, right? Only dependent sources, no independent sources are connected. So if someone is going to ask you what will be the VTH, अगर थेवेनिन वोल्टेज कोई पूछता है क्या होगा, तो आप डायरेक्टली आंसर क्या बोलोगे? जीरो. What will be the answer? Zero will be the answer. Okay, in this case, zero. VTH will be zero. Why? Because there is no independent sources. See, in the circuit, if there is no independent sources, only dependent sources are connected. Okay, so the VTH for that circuit is gonna be zero. Remember, VTH for that circuit is gonna be zero. But in this question, what they are asking is R equivalent, right? Looking from the node. So whenever you try to find the R equivalent, so always keep in mind you have to look like this. Okay, look like this, and that you should always look like a RTS kind of thing, right? Okay, this will help you in the long run. ठीक है, तो अब यहाँ से हम देखेंगे, देखने का मतलब है कि you have to apply one Vx and you have to allow the current to flow Ix, right? And ratio of Vx by Ix is gonna be and one independent source, dependent source, or you can say controlled sources, it is 99 IB, right? So this current is flowing like this. What is the current here? It is flowing Ix plus 99 IB, right? So I think this is IB here, right? So you can say through this branch the current is gonna be Ix plus 100 IB, right? So I believe this is fine for all. This is clear, right? So what you can do here is, now since these two resistances are connected in parallel as well, right? And this voltage source is connected in parallel, so voltage across this, you can find voltage across this in terms of so V, it will be IB times 10K, right? The potential drop across this IB times. So directly you can say that Vx is going to be minus IB times 10K, right? This is the potential drop, right? So in terms of IB you can find Vx, so IB is going to be minus Vx by 10K. Simply you write unit as well, right? Because if you are missing the unit, you might make mistake, because okay, this 100K you can convert as 0.1K, right? Because all resistances are given in in kilograms, so you can write, so not kilogram, kilo ohm, right? So 0.1K you can write, okay, in order to solve the question smartly. So आप इसको भी 0.1K लिख सकते हो, कोई दिक्कत नहीं है, ठीक है? Smart people do like this. Now the voltage drop across this is how much? The voltage drop, you can say Vx is nothing but this is Vx, across this Vx only. So Vx is basically 0.1K times Ix plus 100 IB. Okay, now here only IB is the unknown, right? Ix and Vx we know, right? Vx upon Ix we want. So IB we have got here. In terms of IB, you can replace this IB in terms of Vx and that. Okay, so yeah, fine. So what you can do here is Vx is going to be coded. This is equation number 1, you can say, and this is equation number 2, right? So you keep from equation 1 to equation 2, so that is 0.1K times Ix minus, right? Because IB is here negative, you can say 100 into Vx by 10k. Okay, now what you can do here is you have to just take this 0.1k inside, right? So I'm just going to take inside, so it is 0.1k, and it will go inside, right? So it becomes 10k. 10k gets cancelled, right? So I'm just gonna write this as Vx. Okay, now you can take this Vx that side. So this is 2 Vx equal to 100 ohm. Sorry, this would be Ix now. Here it is Ix, right? Okay, so this is Ix. Okay, now take the ratio, right? So I'm just going to take this guy here. So Vx by Ix is going to be 100 by 2, which is 50 ohm. So it's a simple matter, right? How smartly I have done, okay, avoiding the big in BJT small signal model, in the bottom branch current should be 0 now, as there is no written path. Yeah. Again the question is, you know, you have to be very careful, right? You have to be very careful, understand? Okay, I have taught this and you have to analyze by yourself, right? Okay, understood. Okay. So in this question, you see the answer for this question is 50 ohm. How smartly we have taken. See why we are getting easy answer, because remember, whenever resistances are given in kilo ohm, right? So if any resistance is not given in kilo ohm, so you convert it. Okay, 100 ohm को लिख सकते हो 0.1 kilo ohm, right? Fine. Next is okay, so this is what the question is. There are I think we have discussed many questions. Okay, so these are some good questions from basics, right? I will take more questions, guys, in the next session, so please keep enjoying these concepts. Okay, thank you. We'll meet again. I hope you might have enjoyed the smart solutions. Yeah.